In this video lecture, we will see few problems on radiation. Let us see the first problem. Of the radiant energy 350 watt per meter square incident upon a surface, 250 watt per meter square absorbed, 60 watt per meter square reflected, and the remainder is transmitted through the surface. Calculate the reflectivity, transmittivity and absorptivity. So this is the problem. This is the surface. Now on this surface, an amount of radiation Q dot is falling. Out of the total radiation Q dot R will be reflected. Q dot A is absorbed within the body and the remainder is transmitted. So the total amount of radiation that fall on the surface in 1 second is splitted into three components. One is reflected, second one is absorbed, and the third one is transmitted. So we can write that Q dot equal to Q dot A plus Q dot R plus Q dot transmitted. Here it is given that the total amount of radiation that fall on the surface is 350 watt per meter square and 250 watt per meter square is absorbed. That is Q dot A equal to 250 watt per meter square, and it is given that 60 watt per meter square is reflected. That is Q dot R equal to 60 watt per meter square. So Q dot equal to 350, Q dot A, Q dot R are given. Using this relation, we will get Q transmitted. The amount of radiation, the amount of heat energy that is transmitted is Q dot T equal to Q dot minus Q dot A plus Q dot R. This is given from, you will get this from this relation. So using this expression, we can calculate Q dot T. Q dot T works out to be 40 watt per meter square. We have absorptivity alpha equal to Q dot A by Q dot. This equation we already studied. Absorptivity alpha equal to Q dot A by Q dot. So this will give you the absorptivity alpha as 0.714. Similarly, the transmittivity of the surface tau equal to Q dot T divided by Q dot. So this expression will give you tau is equal to 0.115 and the reflectivity rho equal to Q dot R divided by Q dot. So this works out to be 0.7171. So here the point is the entire radiation that fall on a surface is splitted into three parts: Q dot A plus, we can write the entire amount of radiation that fall on a surface is splitted into three parts: Q dot R plus Q dot transmitted plus Q dot absorbed. Now if you divide the equation 1 with Q dot, we will be getting Q dot, Q dot, Q dot and Q dot. So this Q dot by Q dot, this is equal to 1. Q dot R by Q dot, this term is defined as the reflectivity rho, and Q dot T by Q dot, this term is defined as transmittivity tau, and Q dot absorbed divided by Q dot, this is defined as the absorptivity alpha. That is 1 equal to rho plus tau plus alpha. Alpha plus tau plus rho equal to 1. For a surface, alpha plus tau plus rho equal to 1. Now the second problem is thermal radiation strikes a surface which has a reflectivity of 0.55 and transmittivity of 0.032. The absorbed flux is 95 watt per meter square. Calculate the incident flux. So here This is the surface. As usual, Q dot is incident on the surface, Q dot R is reflected, Q dot A absorbed and Q dot T transmitted. Now, it is given that the amount of heat radiation that absorbed is 95 watt per meter square. Reflectivity is given as 0.55. Transmittivity of the surface, that is also given 0.032. We have to calculate the amount of radiation. We have to calculate the total amount of radiation that fall on the surface. Q dot we have to calculate. For that, we already proved that for a surface alpha plus tau plus rho equal to 1. We have rho and tau already given. So if rho and tau is given, you can calculate alpha using this relation. So alpha works out to be 0.418. This works out to be 0.418. So we have alpha 0.418. Also Q dot A is known. We know that alpha equal to absorptivity alpha equal to Q dot A by Q dot. Q dot A is 95 watt per meter square. Q dot has to be evaluated. Alpha equal to 0.418. So Q dot you will be getting 227.27 watt per meter square.